Good day, good day, good day, good day. Welcome to our YouTube channel. So if you're new here, my name is Tifla, and if you've been here for a while, welcome. And I'm really sorry for letting you for a long time. We're short of equipment. However, now we are trying. We got some new equipment that we'll try to use in order to deliver what we have to deliver. So we just planned to do some of the revision with the grade 12s. So now we are starting with trial paper 1, which we took this question from 2024 trial maths paper 1. But however, we started on optimization because a lot of kids struggle a lot on optimization. So let's just see how we can tackle this question on optimization without wasting more time. And again, don't forget to subscribe if you haven't subscribed, because it will help us a lot keeping on creating this for you. So we are having this question on optimization. Let's just read through the question and then let's see how we can answer that. So the diagram below shows the plan of a veranda which is to be built onto the corner of a cottage. A railing A, B, C, D is to be constructed around the four edges of a veranda. So we can see that these railings, let's use black. So this railing from this corner, it is to be constructed. Right, so let's see what's next. It is given that AB, so this is our AB here below, is equal to DE, which is equal to X. So it means that also this is X. And BC is equal to CD, which is Y. So BC also is equivalent to Y. It is equivalent to that. And the length of the railing must be 30 meters. So to move from A to B to C to D and then to E, the whole length must be 30 meters. And now they say calculate the value of X and Y for which the veranda will have a maximum area. So before we rush to the area, we have to make sense of what we are given. That's one way to start with optimization. Make sense of what you are given. So you can see here that we are given this length X, Y, Y, and X. So if you are given two variables that are different, you have to first make the variables in terms of each other, or find the length of the other in terms of the other, so that you can substitute and solve for that equation, right? So here we are given that X plus Y plus Y plus X is equal to 30. So we can make sense of that so that we can make one subject of the formula. So here it is quite evident that our Y plus X plus X must be equivalent to 30 meters. Now we can add through, so it means that our 2Y plus our 2X must be equivalent to 30 meters. So now we can divide throughout by our 2. So it means that our Y plus X is equal to 15 meters. So now most of the times we want to make Y subject of the formula so that we can deal with the X. So now it means that our Y can be equivalent to 15 meters minus X. So this will be the value of our Y. So here we can place it here. So it means that our Y here, it is equivalent to 15 minus X, and also our Y here, it is 15 minus X, like that. So the next thing is, let's now talk about the area, because now our Y is in terms of X, right? So they said we must find the area of this railing for which it will have a maximum area. So this is the area that we're talking about, that you have to deal with. This is the area that you have to deal with. But we can see that this is an irregular shape. We cannot actually deal with it without knowing the area of this whole shape. Maybe let's just construct a corner here that we can call maybe Z, right? So we can see that this shape here, it is having 90 degrees, to mean that if we construct this shape here up to this point and this point, this shape becomes a rectangle. We cannot say a square yet because we don't know other factors, but if you just know that this shape is having 4 right angles, it qualifies for it to be a rectangle. So to find the area of this inside, it means that we must first calculate the area of this bigger shape and then subtract the area of this smaller shape from that. Once we do that, we can be able to find the area of this shape and then we can optimize that. But let's see all the dimensions of these shapes. We can see that this side is y, this side is y. So it qualifies to make this a square actually, because this is y and this is y. So two adjacent sides, they are equal. So now we can see that the area, now we are talking about the area of what? The area of B, C, D, and Z. B, C, D, and Z. This whole bigger shape. What is the area of that? The area of that, the area of a square, it is side times side, which this gives us y by y. So it means that our area of this bigger shape, it is y squared. So that is the area of the bigger shape. But now we're not interested in this bigger shape, we're interested in this shape that is inside. So we also need to calculate the area of this and then we can subtract from that. So the dimensions of this F, A, Z, and E, how can you find the area of this now? We know that this length here from B to Z, it is Y, because these are opposite sides of a rectangle, but also we have seen that this is a square, so these are all sides of a square are equal, right? So if this is Y and then this is X, so it means that our A to Z becomes Y minus X, like that. Can you see that? So this just becomes Y minus X. And same thing when you are dealing with this side also, this whole side, it is Y. So this side here, to move from E to our Z, also becomes Y minus X. So let's find the area of this smaller shape now. So the area of the smaller shape becomes side by side as well, because you can see that this is Y minus X and also Y minus X. So this area now becomes Y minus X multiplied by Y minus X. So this is Y minus X squared, like that. Can you see that? Yes. So now we're having two areas. We have the area of the bigger one and we have the area of this smaller one. So now we are able to find the area of this one that is inside by subtracting the two. So let's just try to subtract the two. Let's see how we can deal that. So it means that now our area of the railing now becomes Y squared minus Y minus X squared. That will be the area of the railing that we are interested in, this side. So now our area now becomes Y squared, and dealing with this, it will be minus. So dealing with this becomes Y squared minus 2x and then plus X squared. So you know how to multiply out the brackets, right? So now our area becomes Y squared, and then we can have our minus, right, Y squared. because y squared is inside, so minus our y squared. Sorry, here it should be minus 2xy. Yes, minus 2xy. So now this becomes plus 2xy, and then here it will be minus x squared, because we are multiplying out by a negative inside, so every sign changes the inside. I think this pen is not that. Okay, so now our y squared minus our y squared, this just cancels out. So our area now becomes 2xy minus x squared. But let's not forget that our y is equivalent to that, so we can substitute that. So our area in terms of x now becomes 2x multiplied by 15 minus x, and then minus x squared, like that. So let's deal with what's there inside. So now our area in terms of x becomes this multiplied by that will give us 30x, and this multiplied by that will give us negative 2x squared, and then again we're having our negative x squared there. So our area now in terms of x becomes 30x minus 3x squared. So now we're having our area in terms of x. So this is our area in terms of x, but the question now, they said calculate the value of x and y for which this we have a maximum area. So to have the maximum area, it means that we must optimize this, or we must derive this, right? So we can say our derivation of our area now becomes, you know how to derive using the rules, right? So this becomes 30 minus 6x. And now from there, you know that now when you are optimizing, you are substituting your derivation to 0. That's when it will have the maximum area or the maximum whatsoever the situation. So now our derivation to x must be equivalent to 0. So it means that now our 30 minus 6x must be equivalent to 0. So which means that our 6x will be equivalent to 30. So we've taken 6 to that side, and then it became positive, so everything is positive. So our 6x is equals to 30. So now we can divide by 6, so it means that our x now is equivalent to 5 meters. So we have optimized that. But they said find the value of x and y. So now we know that from this, which we already talked about, we have said that our y is equivalent to 15 meters minus x. So y now becomes 15 meters minus 5 meters, which our y becomes 10 meters. So it means that for this to have the maximum area, it means that our x must be equals to 5 and our y must be equals to 10 meters. So our x is equals to 5 and our y is equals to 10 meters. So that's what will happen for it to have the maximum area. If you have really enjoyed this, please show us by subscribing. We are still coming with a lot of questions, and we are picking those questions that gives a lot of tough times. So I think we'll move to probability or maybe financial mathematics, but on this question paper, the trial one. Have a lovely day for the rest of the day and ace your exams.